Aloha everyone! In this video, we'll explore the intriguing contrast between data structure and data architecture. Many people confuse the terms data structure and data architecture because on the surface, they seem to refer to the same concept, organizing data. However, while both deal with managing data, they operate on entirely different levels and serve different purposes. Data structure is about micro-level operations like efficiently storing and accessing data within software programs. On the other hand, data architecture provides a macro-level framework, aligning an organization's data management strategy with its business goals. Together, they create a cohesive ecosystem crucial for modern data engineering. At a micro level, from a computer perspective, data structure refers to how data are stored and accessed within software programs. Computers rely on structured formats such as arrays, hash tables, and linked lists to efficiently process information. These structures determine how quickly data can be retrieved, how effectively memory is used, and how seamlessly applications can perform their tasks. For example, when a search engine provides results in milliseconds, it is because of highly optimized data structures that allow rapid lookup and retrieval of information. On the other hand, at a macro level, from a human perspective, data architecture defines how data are organized, integrated, and managed across an entire system or organization. Instead of focusing on how data are stored at the computer code level, data architecture is concerned with how large-scale data environments are built to support business intelligence, analytics, and decision-making. Several key components of data architecture include data warehouses, data lakes, and data meshes, each serving different purposes. A data warehouse is a centralized repository that stores structured data optimized for querying and analysis. Businesses use data warehouses to store historical sales records, customer transactions, and performance metrics. For example, a retail company might use a data warehouse to analyze monthly sales trends. This is a mature and well-established approach, but it's not always the best fit for organizations dealing with highly diverse, rapidly changing data. A data lake is a concept aimed at addressing the limitations of data warehouses. This is a storage system that holds vast amounts of raw, unstructured, or semi-structured data for future use. Unlike a data warehouse, a data lake does not require data to be pre-organized. A streaming service like Netflix, for example, might store video logs, user behavior data, and raw viewing statistics in a data lake before processing them for personalized recommendations. A data mesh is a decentralized data architecture where different business domains manage their own data, rather than having a single central repository. This is useful for large organizations where different teams, such as marketing, finance, and product development, need to control their own data while still ensuring interoperability. For instance, a multinational corporation might implement a data mesh to allow different regional offices to maintain their own sales data while still making it accessible across the company. While data warehouses and data lakes are foundational, newer architectures like data lakehouses, data fabric, event-driven systems, Lambda architecture, Kappa architecture, and hybrid cloud solutions are evolving to handle the increasing complexity of big data, AI, and real-time analytics. But it is beyond the scope of this short video to discuss each of these. I just want to let you be aware that the only constant is change. The state-of-the-art technology today may be outdated later. One of the most significant advancements in data architecture today is cloud computing, which has transformed how organizations handle data. Cloud computing is the practice of using remote servers hosted on the internet to store, manage, and process data, instead of relying on a personal computer or local servers. It provides on-demand access to computing resources such as storage, databases, networking, and AI capabilities without requiring users to maintain physical infrastructure. Think of cloud computing like electricity from a power grid. Instead of every household or business generating its own electricity with private generators, they simply connect to the grid and use as much electricity as they need, paying only for what they consume. Similarly, cloud computing allows businesses and individuals to plug into powerful remote servers to store and process data without needing to own and maintain expensive hardware. With the cloud-based data architecture, companies no longer rely solely on physical servers. Instead, they leverage cloud-based platforms such as Amazon Web Services, AWS, Google Cloud, and Microsoft Azure to store and process vast amounts of data on demand. This shift has made data architecture more scalable, cost-effective, and accessible than ever before. The importance of data architecture has become even more apparent with the rise of artificial intelligence, AI. Recently, Meta, Microsoft, Amazon, and Alphabet, Google's parent company, are projected to collectively invest $325 billion in capital expenditures and infrastructure. OpenAI relies on Microsoft Azure to train and deploy GPT models, whereas Anthropic, Claude AI, uses Google Cloud for training its models. Meta is investing billions in AI infrastructure, but is not a public cloud provider, which limits its AI scalability compared to AWS, Azure, and Google Cloud. The AI leader of the future will almost certainly be a cloud leader too. The company that masters both AI and cloud infrastructure will not only dominate AI development, but also control who gets access to the best AI models and how they're deployed worldwide. There are several areas where cloud computer and AI are symbiotic. The first area is about massive computing power. AI models, especially deep learning frameworks like ChatGPT, demand immense computing power. Cloud platforms fulfill these requirements by offering scalable GPU and TPU capabilities, making advanced model training and deployment seamless for engineers. The second area is about data storage and processing. AI depends on big data for training and inference. Cloud computing offers scalable and secure storage solutions, along with distributed computing frameworks to process vast amounts of data, making real-time analytics possible. AI as a service, AIaaS, is another crucial intersection between AI and cloud computing. Cloud providers offer AI services, such as machine learning, ML model hosting, automated AI model training, natural language processing, NLP, and computer vision. These services allow businesses to leverage AI without investing in expensive on-premise infrastructure. By integrating AI with edge computing, cloud providers bring data processing closer to the source, cutting latency and bandwidth costs. This approach benefits cutting-edge applications, including autonomous vehicles and real-time analytics, ensuring efficient data responses on the spot. To summarize, while data structure and data architecture both deal with handling data, they operate at different levels. Data structure is about efficiency at a micro level, focusing on how computers organize data for fast processing. Data architecture, on the other hand, is about scalability and accessibility at a macro level, ensuring that humans can effectively store, manage, and analyze data across entire organizations. I hope this video can clarify these two concepts. Thank you for watching. Mahalo.